Welcome back to Get XAML. So in the last video, you have seen the discrete random variable and probability mass function. So in this video, we'll learn about continuous random variable. For that, we'll have probability density function. So the probability distribution, we call it as probability density function, PDF. In discrete case, we call it as PMF. Now let us understand the definition. So same 3 points you have to satisfy for the distribution to be probability density function. The first one is f of x should be greater than or equal to x. That is same. Then second one is the sum of all the probabilities is 1. Why you written minus infinity to plus infinity integral? I'll explain. Then the third one is p of a less than x less than b is integral a to b f of x dx. Let us try to understand. This is the definition of the probability density function. Why it is integral? What is the difference between discrete and continuous? See, already I learned the concept. So this is, say, x equal to 0, 1, 2, 3, 4. This is for discrete case. See, I am defining point. So this is, I am calculating the probability at a point. Okay. So this is p of x equal to 0 and so on. Because in discrete, I can have countable numbers 0, 1, 2, 3, 4 like that. But in case of continuous, if you remember the example, height, we say for example 175.6 centimeters. If this is the height, so this is a continuous variable. Now I cannot have discrete points. So basically what is that I am doing? I'll create a curve like this. Okay, this is a curve. And then I am defining, say, 2 points or intervals. So this is A and this is B. Now the integral means what? If you know the integration concept, integral actually finds the area within the curve. So this is A, this is B. In this interval, I am finding the curve. This is actually the probability density. So we cannot have the discrete values. See, this is a continuous curve. I can have infinite number of points between the interval A, B. That is the concept here. That is why we, in this probability mass function, you use summation. That is, we know particular point, so you will add them p1 p2 like that. But here we don't have discrete case, so you have to integrate those points between A and B. So that is the definition. So why it is written as like this in the interval means because of this reason, because it is a continuous, we cannot specify a particular point. So that is written as PDF is given as integral A to B in the interval f of x dx, this function. So we'll take the example, we'll understand. So before going to that, why it is not possible? Because point probability at any point, your integral will become 0. Why? For example, say that I want to calculate p of x equal to a. In discrete case, it is possible. But here, if I take integral area under the curve at the same point, a to a, it can be any function. If I do like this, what is that I will get? Between a to a, I will get it as 0 only. So the point probability in continuous case is always 0. That is the reason we go for integration between the intervals. We cannot have a point probability like discrete case. Probability at an exact point is always 0 because probability is defined as a area under curve and a single point has 0 width. There is no area for a single point, right? So formally we write x equal to a, that is p of a is less than equal to x less than equal to a plus some delta, okay, some epsilon value. In the limits, I will explain what exactly it means. So for time being, you understand point probability means 0 in continuous case. Now let us take an example, you'll understand. So this is a probability density function they are given f of x. Now you have to verify whether it's a PDF or not. They claim it's a PDF. Now you have to check the conditions. What is the first condition? F of x should be greater than or equal to 0. The first two conditions are same. Now, so put, and they are given in this interval. See, this curve x square by 3 will be valid only in this interval. This is very important in continuous distribution. When I say minus infinity to plus infinity, this is the lower bound. This is the upper bound. Okay, lower bound. They act as the lower bound and the upper bound. So when I solve the problems, I will put them as A and B. A is the lower bound. B is the upper bound. So that means what, for this function, minus 1 is the lower bound, 2 is the upper bound. So in this minus 1 to 2, you put any values, then you should get f of x is greater than 0. So let us say I will put f of minus 1. F of minus 1 is x square by 3. So square by 3, put minus 1 whole square divided by 3. So this is equal to 1 by 3, which is greater than or equal to 0. So take f of 2. So x square by 3, that is equal to 2 square is 4 divided by 3. So this is also greater than equal to 0. Okay. So this condition holds. The second condition, what it says, integral lower bound to upper bound, that is lower bound is minus 1 to 2 f of x, let me write infinity to minus infinity to plus infinity f of x dx should be equal to 1. That means what is the lower bound? Minus 1. Upper bound is 2. The function is x square by 3 dx should be equal to 1. So let us test this. So integral of x square by 3 is x cube by 3. Then put the value minus 1 to 2. This will come to be 1 by 3 into, into, so 2 cube is 8 divided by 3 minus 1 cube is minus 1 divided by 3. So this comes out to be 1 by 3 into 9 by 3. So this is 1. Therefore, this is also satisfied. Now the third case is, you already defined it. So minus 1 less than x less than 2 is equal to your a to b x square by 3. So dx, this is already established. A to b is minus 1 to minus plus 2. So this holds 5 because already I calculated these values and got it as 1. So it is integrable in that. So that is how you have to verify a probability density function. Next. So now we'll see what is cumulative distribution function, how we will find it. Same, the definition remains same for CDF, f of x equal to p of x less than or equal to x. So from here you will start here. See, there you done it as summation of x f of t. Okay, for t is equal to 0, 1, 2 up to whatever values. But here the continuous case, right? So same thing, f of t dt, this is a function, so to integrate it. Starting from where? Starting from the lower bound till you reach your x, this less than or equal to x, f of t dt. The properties remain same. F of x is non-decreasing and it lies between 0 to 1. So one more thing here is, if derivation exists, then if you differentiate this f of x, what we get is CDF, then we will get back our PDF function. You will see in examples, you'll understand. Let us see how to form the CDF. So this PDF is given. Let us find the cumulative distribution function. So CDF t is equal to f of x, capital F of x. So first what you have to do, see, this is given by what? Minus infinity to x, okay, minus infinity to x f of t dt. Now put t in this f of t means what? So instead of x, there is t. So this will be minus infinity is the lower bound, right? Minus 1 in our case. Till x less than or equal to x. X may be what? Till 2. So continuous. I cannot say 0, 1 or 2. It will be till 2. So I don't know what is that. So I am calculating for x. So x lies in the range minus 1 to 2. That is the meaning. F of t dt. So t square divided by 3 dt. Now you integrate this. So it will be 1 by 9 or t cube by 9. From there, minus 1 to x. So this will be x cube, okay, by 9 minus 1 by 9. So that will be x cube minus 1 divided by 9. Okay, this is your CDF function. So just simple thing, only substitute t, integrate from lower bound to the x value. Then you will get that CDF function. Next. So there are some rules. If you remember the discrete case, you have learned some rules, right? Here it is very relaxed. Means there no their point probability occurs. So that means what? P of x equal to 0, P of x equal to 1 are point probability. Here it's a curve. So CDF at any point, if P of x is less than or equal to, is also equal to P of x less than A. In discrete case, they both are different because it's a point probability. But here, when I draw something like this is A, equal to A less than A is almost here only. That's why I told you limit of that x tends to some value. This A plus C is always same as A. That is what is that they are proving. Okay. So in the discrete case it is different, but in the continuous case there is no change. This means the same. Okay, with some error. So but while solving the problems, we will not consider as different cases. Next. Similarly, P of x greater than A is equal to 1 minus f of A. So you can calculate directly using the CDF. Next. Now, this is another case. P of A less than x less than B is equal to P probability of A less than or equal to x less than or equal to B. See, that is what I said. So there is no difference between less than or less than equal to or greater than or greater than equal to in the continuous case. So they are very simple to solve. But in discrete case, please observe if they give the question, be careful. In the discrete case, you have to properly find using that line. Okay, let us take some few example. So they are given a PDF. The PDF has piecewise function here. Okay, x in this interval, 2 minus x in this interval, 0 in the other intervals other than these two. Now they are saying 1 unit equal to 100 hours. You have to find probability of running a vacuum cleaner less than 120 hours. 120 hours means how many units divided by 100. So it is equal to 1.2. So what is the random variable? Probability of less than x less than 1.2. Okay. Now you see, directly don't integrate. There are two functions here. So from 0 to 1, it is x. It is less than 1.2 means what? I have to start from 0 till 1.2. So 0 to 1, x dx is the interval here. Plus, don't do it as 0 to 1.2 and then integrate with some function. It will be wrong. Then from 1 to 1.2, it is 2 minus x dx. Okay. So this will be x square by 2 in the interval 1, 0 plus this will be 2x minus x square by 2 in the interval 1.2 to 1. If you substitute and calculate, You'll get 0.68 as the answer. This is A. Now B. They are saying between 50 and 100. So divide by 100 because 1 unit is 100 hours. They are given the density function in units. Okay. If they would have mentioned here 100, 0 to 100 or whatever, then it would have been directly 100. Now, what is that to find? 0.5 less than x less than 1, right? So this is equal to integral. So directly there is only one function from 0 to, it falls between 0 to x. So it is 0.5 is the lower bound, 1 x dx. Okay. So this is x square by 2, 1, 0.5. So this comes out to be 0.375. This is how you have to observe and solve the problems. Next, they are given another density function here. So this is verify is this in the interval is equal to 1. That is it a PDF? That is what they are asking. So just integrate. So integration 2 by 5, keep outside constant, x plus 2 dx in the interval 0 to 1. So this will be equal to 2 by 5 x square by 2 plus 2x in the interval 0 to 1. So this will be 2 by 5 1 by 4 plus 2 minus 0. Okay. So you will get 1. Okay. Check whether I made any mistake, but you will get 1. Okay. Similarly, B. Integration of from 1 by plus 1 by 4 to 1 by 2. This will be, find out that value. What will be that value? So again 2 by 5 x square by 2 plus 2x in the interval. What is the interval? 1 by 2 to 1 by 4 to 1 by 2. So you will get it as something as 0.2375. Okay, just verify your answer. Similarly, one more. I'm just solving to say that this doesn't matter. Okay, so I'll just write the equation, then you can solve and get the answer. So this is A, 2 by 27. Don't worry, that's what I told. These problems are simple, but when you go for marginal, conditional, probability distribution, then we'll see some complex problems. So dx in the interval C is very important. X less than 4. Many people just write 4 here and 0 here. This is wrong. See the interval here. It starts, lower bound starts from 2. So be careful. So this answer will get it as 0.5926. You can just calculate and check. Then another one is the interval is 27. So less than or equal to 3, greater than or equal to 3. That means what? Start from 3 only. 3 to 4, 1 plus x dx. This value will get it as 0.33. So next we will start with the advanced concepts using the distributions. There are different conditional probability distribution. Okay, and then marginal distribution, and then we'll start with the expectation and all those things. So we'll continue in the next video. Thank you.